Okay, in this lesson I want to look at Theorem 16 and a couple of examples. So Theorem 16 says for a triangle or a parallelogram, base times height does not depend on the choice of base. Remember, base times height is involved in finding areas for parallelograms and triangles. The area of a parallelogram is base times height. The area of a triangle is half base times height. So all this theorem is saying is if I take any triangle like so and I place it down here, I can find its area by measuring its base and measuring its perpendicular height. In this case, that would be the perpendicular height. Okay, perpendicular to that line. But it doesn't matter what base I choose. And try to rotate these things and see how we get on. So I could choose this to be my base down here. So I could place that down like that on that base, in which case my perpendicular height would be that length. Or I can, take that triangle and rotate it around in a different way and make that the base. Just like so. Get that up in line. And if I do that, well, the perpendicular height then is that distance. Okay? So base times height, I can use any base and any height. These heights are all called altitudes. So every triangle has 3 different altitudes. So we've 3 altitudes. But the area of a triangle, you can choose any base and measure any altitude and work the area from there. Can I look at a couple of examples here? Using the line segment AC, that's this side over here as the base. Express the area of the triangle in terms of x. Well, if I make AC the base, the perpendicular height is that height there, x. So we know the area is equal to 1/2 times the base times the perpendicular height, which is 1/2. The base here is 5 units times the perpendicular height here would be x. So what I'm getting there would be, doing all my multiplication, that would be 5x over 2. So the area of this triangle is 5x over 2. That's in terms of x. That's using this base here. If I want to use the line segment with endpoints as B and C as the base, let me color code this. So let me put this in as the base. Well, if that's the base, we have a different height. This is my altitude. This is my perpendicular height. So using that base and that perpendicular height, we'll find the area of the triangle is 1/2 times that base, which we're given is 4, times the perpendicular height, which we're also given is 4. And 1/2 times 4 is 2. 2 4s are 8. So that's 8 units squared. The key detail to understand is that it doesn't matter what base I use, the area doesn't change. So the area I calculated here should be the same as the area I calculated here. So 5x over 2 must equal to 8. 5x multiplying on both sides by 2. 5x is 16. Dividing on both sides by 5. 16 divided by 5 will be 3.2. So x would be equal to 3.2 units in that case. Whatever those units are. The choice of base does not affect the area. Okay? It does not affect the base times height calculation. And look at that in a parallelogram. I want to find the area of the parallelogram. Well, I know the area of a parallelogram is base times height. In this case, the base is 12, the perpendicular height is 8. Is 96. But I don't have to use that base if I want to find the value of g. Well, g is the perpendicular height from this base. So if I looked at this, if I rotate it around, put it on this base, g is the perpendicular height. We know the area of the parallelogram is base times height. We've just found that's 96. And the base here, if I use this 10 as the base, that would be 10 times the perpendicular height g. So from that we can work out that g would have to be 9.6 units. So base times height does not depend on the choice of base. Okay? So they're important things. 6.2 in your textbooks at this stage. You should be able to complete pretty much everything in there. Okay.